part 2 of lesson 3, we're going to skip the bottom of page 10 and the top of page 11. We're going to come back to that later. So if you're looking at the bottom of page 11, we've got a trinomial divided by a binomial. Not that little monomial where we can just simplify everything, but the binomial. So when we have that, we need to either use long division or synthetic division. We're going to start with long division today. All right, long division is what you've talked about when you were in elementary school using that long division. What we used when we did those imaginary numbers. So just to recap, if I was going to divide 3 into 831, I want to start by seeing how many times 3 can go into 8. It can go 2 times. Then I'm going to multiply. 2 times 3 is 6. And I'm going to subtract. 8 minus 6 is 2. I'm going to bring down my 3. Then 3 times what will get me close to 23, which is 7. 7 times 3 is minus 21. So that's 2. And we'll bring down my 1. And 3 times 7 again will give me 21. So I'm left with no remainder. Okay? Now, what if you're given, let's do another one. If I have 4 divided by 9 into 955. Well, 4 can go into 9 2 times. Multiply those with 1 left over. Bring down 5. And 4 times 3 will get me close. 3. Bring down 5 again. Now, 4 times what's going to get me close to 35, and that's 8. It's not going to give me exactly 35, but it's going to get me really, really close. So I've got a remainder of 3. Now here, when we did that with imaginary numbers, we were focusing on that remainder, but here we're actually doing the division. So when I write my answer, 238, I'm going to put that remainder over my divisor in 3/4. If you do that into a calculator, you type in 955 divided by 4, it's going to give you 238.75, which is the same thing as 238 3/4. The purpose of showing you this is how to rewrite that remainder when we do polynomials. It's the same thing. Okay, so now that we've taken a trip back in time to a division, now we're going to look at page 12. Here are your 8 steps for long division. In case you get stuck and need to see something in print, here are some steps. On to the next bottom of the page. Alright, so I've got my trinomial and I'm going to divide it by my binomial. So I'm going to set it up just like a normal old division problem. 2x squared minus 5x plus 3. Okay, just like when I divided that 3 into that 8, I looked at that first term first. So I'm going to do the same thing here. So I'm looking, what times x can give me x squared? That's x. Now, this is the part that's going to be tricky. I've got to go back, I'm going to go back to my example. When we put 2 up here, we said 3 times what will get me close to 8? And we said 2. Then we multiplied that to give us this. Well, I have to do the same thing with this long division. But I've got a plus 2 on the outside of it. So that x on top has to get distributed to everything. So x times x is x squared, and x times 2 is plus 2x. Now, our goal in the other example was to get rid of that 8. So here's the part where I have to go back and I have to change all my signs. If it's positive, I'm going to change it to negative. Negative, I'm going to change it to a positive. So in this case, my goal is to get rid of that x squared. So if I didn't change it, I wouldn't have gotten rid of it. But now that I've made it negative, those are going to cancel out, which is the whole goal. Now I'm going to look at negative 5x minus 2x, which is negative 7x, and I'm going to bring down my plus 3. Okay? Now I want to look at what times x will give me negative 7x. Well, the only thing missing, and that's all I'm really basically trying to find is what's different between the two, is that negative 7. That's the only thing that x out here doesn't have, is the negative 7. So I'm going to do the same thing again. I'm going to distribute back out. And if you'll notice, those 7x's won't cancel the way I've gotten them. So I've got to go back and change my signs. Now they'll cancel out. 3 plus 14 is 17. Because I have nothing left to bring down, and I can't get this x to ever look like that 17, I'm done. That 17 just becomes my remainder. So to rewrite my answer, x plus minus 7, so got that from the top of the dividing house, and I'm going to put my remainder over my divisor. Just like we did in that second problem here. We took our remainder and put it over our divisor. We're going to do the same thing with any remainders in this polynomial division. So there's my answer. It's a very messy looking answer. Alright, at the top of page 13, got another one. This one's a little bit bigger. So I'm going to rewrite it using the dividing house. 5x plus 2 divided into 5x cubed minus 13x squared minus x plus 2. Now if you'll notice, the dividend is already in standard form. I've got a 3, a 2, a 1, and a 0. That's important. Okay, just get in the habit of looking for that. Alright, so now we're going to divide 5x to 5x cubed. The only thing missing between those two numbers is an x squared. Alright, now I'm going to distribute that back out. So 5x times x squared was 5x cubed, which was the whole goal. 2 times x squared plus 2x squared. Now I've got to go back, change signs. That's now going to cancel, whole goal. Negative 13x squared minus 2x squared is negative 15x squared. And I'm going to bring down that negative x. Okay? Now I'm looking at 5x to negative 15x squared. There's a big difference between those two things. So I'm going to look at 5 to 15 first. That just needs a negative 3. Alright, now I'm going to look at x to x squared. That's missing an x. So to get from 5x to negative 15x squared, I need a negative 3x. So I'm going to multiply that back out. Alright, if you'll get to this point, negative 15x squared and negative 15x squared don't cancel out. So I need to remember to change all my signs. And if I do it to that first one, this section and the 15x squared, I've got to remember to do it to the 6x. So now those will cancel. Now I've got negative x plus 6x, which is 5x. And I'm going to bring down my plus 2. Alright, so 5x to 5x, I don't need anything different. But because I've still got stuff down there, I've got to know that that's a 1. So 1 times that will give me that. Alright, nothing cancels out yet, so change my signs. 2 minus 2 is 0, and I don't have a remainder. So my final answer is x squared minus 3x plus 1. And the opposite of division is multiplication. So if I were to multiply 5x squared times x squared minus 3x plus 1, I should get 5x cubed minus 13x squared minus x plus 2. So that's a way to check yourself. If you get a really weird answer that you think just doesn't make sense, multiply it back out real quick using your box or your foil and just check it. Alright, if you'll find some room in your foldable, I'm going to show you an example of what I was talking about all the parts not being there. So if you were given 3x squared plus 1 divided by x plus 1. If you'll notice, in that 3x squared plus 1, I'm missing that linear term, that x term. So when I rewrite it, I don't want to add any value to that number that's not really there. So I'm just going to stick in a 0x. It's just a placeholder. I haven't added anything to this equation or taken anything away. It's just a placeholder that's going to make it a whole lot easier for when I divide. Alright, now I can go from x to 3x squared, which is just the 3x. Distribute everything out. Nothing cancels, so I gotta change my signs. Alright, now this is where adding that 0x in is gonna save you a big headache. 0x minus 3x is negative 3x. So I didn't add anything to it, I just made it a little bit neater to see. And I'm gonna bring down my 1. X to negative 3x just needs a negative 3. Distribute.